Try to solve another Leetcode problem, 155, mean stack. So we are giving a class of mean stack, and we have this kind of a method. And this is a design problem. We need to design a stack that supports all the operations like the push, pop, top, and get minimum. So the only difference from our normal stack is that we have a get minimum. So the get minimum is retrieves the minimum element in the stack. Yeah, we should know about that if we have a stack. So for example, if we can define a self.stack, we can have such operations. We can have the push. So self stack and dot push. It should be append in Python. We can append a value, and we can also use the pop. And as you can see, remove the element on top of the stack, and the top is get the top element, and get min is the minimum element. And we must implement a solution with O1 time complexity for each operation. And we should know about that. It must be O1 time. And let's check others. And the pop, top, and get min operations will always be called on non-empty stacks. It means that will always be valid. So for example, for the pop, what we need to return, we need to let's just remove the element on top of stack. So we just need to remove the element. So self.stack and dot pop. We can directly use a pop. And for the top, get the top element. So this means we're gonna so this is push and get the top element. So we're gonna get the top element. So it's gonna be self.stack with -1. But how to calculate the get minimum? Maybe we're gonna use a variable, but that variable is not enough. Because the minimum is just inside a range. So for example, we have an array, and there will be numbers like 2, 1, 3, 4. But we should always keep the minimum element. From here the minimum element is 2, but from here the minimum element is gonna be 1. So what about here? It's gonna still be 1. And what about here? It's gonna still be 1. It's gonna be the minimum element of all the range. So this means we cannot use a variable. We cannot use a variable to store the minimum element. We have to use another array, or we can use a stack. So this means we're going to use another stack to store the minimum element. So in this way, we can use the get minimum in O1 time. So in this way, all the operations will be O1 time. So we're gonna prepare another variable. It's gonna be another stack. It's gonna be the minimum. It's gonna be a stack. So while we push an element, so inside we're gonna get an infinity, because for each of the time we're gonna compare with the last element in the self.minimum stack. The last element compared with the current element, we're gonna get the minimum element. So self.minimum would append a value, and this value is going to be the minimum of self.minimum with -1. So currently it is infinity, and another element is our current element, it is val. So in this way we can keep record of the minimum element at the end of the minimum stack. So while we pop an element, so self.minimum.pop this element. And while we get to the top element, we just need to use the stack -1. And for the get minimum, we can just return the self.minimum. Self.minimum with -1. Let's just check. Do we need to return something? So this is just initialization of the stack. We just initialize it. And push, we just need to push something inside. And pop, we just need to pop it out. We don't need to return something. We just need to pop it out. And the top, get the top element. I don't know. I'm not sure. Do we need a return or not? It is not mentioned. Yeah, as you can see from here, the input and the output. So it seems for the output, yeah, it's not mentioned in the description. Normally the description should say about that, should tell us what we need to return. Do we need to return or not? But it didn't give us any description about that. But we can guess. So from here, we used the get minimum, yeah, and pop and the top. It seems the pop we don't need to return anything, but for the get minimum and the top we need to return something. So I'm gonna use a return, and here I also use a return. So this makes sense. Yeah, because if we want to get the top element, basically we need to return something, or we need to get the minimum, we need to return something. But if we want to pop out an element from the stack, we just need to pop it out. Yeah, and also for the push. I think that's enough for the problem, and each operation will be just in O1 time. Yeah. Now let me run it to stack. As you can see, it works. Now let me submit it to stack if it can pass all the testing cases. As you can see, it passed all the testing cases and it's pretty fast. So why it always works? Why I use infinity at the beginning? Yeah, because it is always valid. I mean, the pop, top, and get minimum operation will always be valid. So why not? I just give a infinity for my self.minimum stack. Yeah, I just give an infinity. So what about the next number? If I were to put a number, for example, I put a 2 inside. So yeah, inside of the stack, I will have a 2, because 2 compared with infinity, it's gonna still be 2. Yeah. Next, if I were to put a 1, yeah, what will be inside my minimum stack? It's gonna be 1. Yeah. And what about next? Because 2 compared with 1, the minimum is 1. What about next? It's gonna be 1, right? And inside of the stack, it's gonna be 2, 1, 3. Yeah. Now, if we were to get to the top, so we're gonna get this 3 from the stack. So this is the stack. So what about we get minimum? We're gonna get this 1 from the minimum stack, because from here this value is 1, and this 1 recorded the minimum value. This is right. Yeah. So what about we pop an element? So if we pop out an element, we pop out this 3, and we pop out this 1 at the same time. Now what about we are going to get the minimum element? Yeah. So we get the minimum element. It is still 1 from the minimum stack. It is still stored there. So in this way, we can store all the minimum element inside a minimum stack. Yeah. And thank you for watching. See you next time.